This is a guide to data frames. A data frame is one of the basic data structures in Maple. Data frames are a list of variables, known as data series, which are displayed in a rectangular grid. Every column, otherwise known as a variable, in a data frame has the same length. However, each variable can have a different type, such as integer, float, string, name, true/false, and so on. This makes data frames an ideal storage device for any type of heterogeneous data, so different types of information being stored in one place. Here we see a sample of a data frame. We have a number of columns. These are the data series, and each one of these has a different type. This has type integer, type float, type integer, type symbol, type string. When printed, data frames resemble matrices in that they are viewed as a rectangular grid, but a key difference is that the first row, what you see here, corresponds to the column names, and the first column corresponds to the row names. These row and columns are treated as header meta information and are not a part of the data. Moreover, the data stored in a data frame can be accessed using these header names as well as by the standard numbered index. The following example page shows a number of common tasks while working with data frames. If you'd like to follow along at home, go up to your help search and simply type in DataFrame, guide, and this will bring up the same help page for you. So this video is going to be a little bit different. In this video, we're going to step through a number of examples that seek to answer very common questions that are asked about data frames and working with these structures inside of Maple. We're going to start with easy examples. We're going to talk about creating a new data frame, describing a new data frame. But then we're going to get into these common operations, such as adding a new column or row, removing a column or row, dealing with missing values. We'll talk about reshaping data frames. We'll talk about changing the data type of a column. So this is really meant to be an immersive and extensive video that's going to talk about a lot of different topics within data frames. Let's start with a quick example of creating a new data frame. Data frames are rich containers for information that can store multiple types of data. For example, the following vectors contain information on 3 berry variants: raspberries, grapes, and strawberries. So to begin with, what we'll do is we'll start by declaring some of our variables. So we'll start with here genus, and this is going to be a vector of type string. Next we have nutrition, energy per 100 grams in kilojoules. This is type integer. Nutrition, carbohydrates per 100 grams in grams. And this is of type float. Tons produced worldwide in 2011, type integer. Top producing country in 2011, and this is type name. So DataFrame can take all these different vectors and they can put them all together into one data structure. So we stitch this together using the DataFrame command, and we give in this vector notation, these triangle brackets, each one of our variables separated by the vertical bar. So it can be observed that in the above data frame, the row and column names are equivalent to the index value. So if we want to look at this value here, it's going to be df1, 1. The row and column names can be specified using the rows and column options respectively. It can also be useful to specify the types of data in each data series using the Datatypes option. So we're going to use the same command as before, the DataFrame command. We're going to give it the same list of variables, but now we're going to specify our column names using the columns option. So columns is equal to energy, carbohydrates, total tons, and so on. Rows is equal to raspberry, grape, strawberry. Data types equals integer, float, integer, anything, string. I'll hit return here. And now we get a much better typeset data frame where we're seeing all of our variables are shown here. So we have the energy variable on this column, carbohydrates, total tons, top producer, and genus. So there's one important note I'll mention at this point. It's also important to note that the vectors included in a data frame should have the same length. If the vectors have different lengths, an error will likely be returned. In our next example, we'll describe a data frame. The describe command prints a description of the structure of a data frame, including the number of observations, or rows, the number of variables, or columns, as well as the type of each column, if this has been specified. In addition, for numeric columns, the minimum and maximum values are displayed, and for true, false, string, or name columns, the distinct levels are given. So let's see this in operation. Let's just do describe of our previously entered data frame. So here we can see this is a description of our data frame. We have 3 observations for 5 variables. The first variable here is energy, type integer. Our min value is 136, max value is 288. Carbohydrates follows in a similar path. For top producer or genus, we see here that we get a tally, so each one of the levels is represented with one observation. So USA has one, Russia has one, and China has one. Indexing entries in data frames. Unlike matrices, data frames can be indexed using column or row names. For example, to view the energy in kilojoules for raspberries, we can do DataFrame, and as our indexing values give raspberry, energy. So this is similar to what we would have done for the matrix. We would have done df1, 1 to get that same value out. One important thing to note is that above, the index follows the convention row, column, and a single value is retrieved. If a data frame is indexed by a single argument, this indexes by column, and the respective column is returned. So for example, to retrieve the values for all berries for the energy variable, we'll do df of energy, and that gives us back a data series with corresponding values of raspberry, grape, and strawberry. And this will be the same as doing df of 1 to retrieve the first column. To return an entire row, for example, the entire row for raspberries as a data series is given by df of raspberry, and this tells us to give all values for raspberries. So we see energy, carbohydrates, total tons, top producer, and genus. Similarly, if we did this with numeric indexing, we would do df1, and this would return the same data series for us. So there's a couple of examples I'll recommend at this point. There's some more examples such as indexing a data frame or subsets of data frames, which would be good supplementary materials to review after this session. Changing values in a data frame. Changing values in an existing data frame can be done in a similar way to other data structures in Maple. Simply assign to the index position that you want to change. For example, to change the value for carbohydrates for grape, we'll do df grape, carbohydrates, and we'll set that equal to 20. If I do df semicolon, we'll then echo back the changed data frame. So here now we see grape carbohydrates is 20. And before we move on, we can also do this using numeric indexing. So I'll just set the value to what it was before. So we'll do df of 2, 2, 18.1. And we can see that we've changed the value back for carbohydrates for grape. Next, let's talk about some details about the data frame structure. There are many useful commands for querying information about the structure of data frames. For example, num_elements returns the total number of elements in a data frame. The upper bound command returns the dimensions of the data frame. So this is the number of rows and columns. To get the number of rows on data frame, put a 1 as the second argument to upper bound. So we'll do upper bound df, 1. To get the number of columns in the data frame, put a 2 as the second argument to upper bound. The Datatypes command returns a list of the data type for each of the columns of data. Here we can see integer, float 8, integer, anything, string. So this is also a good time to very quickly go back and mention something. If we have a data frame in our Maple session, and we open up our context panel, we can actually do a number of queries directly to the data frame using the context panel. So if we open up the context panel, we can see queries. We can get similar things. We've got number of observation, count missing, count the number of entries in a data sample. We can go through here. We can do data analysis. We can do data manipulation. We can do quantities. We can do all of this directly from that context menu. So in the rest of this talk, I will be using commands. I did quickly want to mention that the context menu is an option for running any one of these operations directly in a data frame. How to change column names. Data frames can have both row and column names. In the above example, these were added to the data frame using the columns and rows options. To retrieve the current list of column names, the column labels command can be used. So these are our column labels that we have in our data frame. The subs column label command returns a data frame with a modified column label. So now we can see we've changed the top producer column name to country. Adding a new column or row. The append command appends another column or row to an existing data frame. The arguments for the append command specify the data frame to append to, the data to append, and optionally the orientation and name of the new data, which can be a data frame or data series. The following adds a new column to the data frame corresponding to true-false values for if the given berry is a botanical berry or not. So we do data frame, we use the append command to our existing data frame, a new vector, false, true, false, and the label for this new vector is going to be botanical berry. I'll press return. We've now appended a new column to our data frame for botanical berry. We can see that raspberry is false, grape is true, strawberry is false. If we have a new row of information on blackberries, such as the following data series, so here we have a data series with values for each one of our previously mentioned variables. So I'll declare that data series. Here's the data series. This row can be added to the existing data frame, again using the append command, but we use mode equals row to specify that we're adding a new row instead. We're also giving this row a label of blackberry. So now we have a new row, blackberry, with energy values, carbohydrate values. However, we don't have a value here for total tons. This was not a part of the data series that we add here. So this is actually unknown for that data series. So when this is appended to the original data frame, since there's no value for total tons, the value is left undefined where the data is unknown. For more on missing values, there's a section below where we talk about dealing with missing values. Removing a column or row. The remove command removes a selected column or row from a data frame. This command is very useful when doing further analysis when using commands that require the arguments to be purely numeric, such as visualizations and statistics. So as an example, let's remove the non-numeric genus, country, and botanical berry columns from our data frame. To do so, we'll use remove from the data frame the following list of column names. So what we get back here is the same data frame, but now we've removed anything that was non-numeric. So we've removed those 3 columns. We can also remove a row using the mode option. So if we do remove from our data frame the row grape and mode equals row, we get back our same original data frame with the grape row removed. Now you may have noticed that when we did the second remove here, this actually did not have the same list of columns removed as we saw in the first example. So this is because when we do remove, it actually does not do the removal in place. So if I do now call back to df, we're going to see that our original data frame has not been changed. So if you did want to do a removal where you did want to change the data frame, you would have to do DataFrame :equals and then remove of the relevant column or row from that structure. Dealing with missing values. Some datasets may have missing values. In the data frame for blackberries, it can be observed that the value for total tons is undefined. There are several commands for dealing with missing values in data frames, including the drop missing and fill missing commands. Fill missing can be used to fill missing values with another value. So for example, here we can fill the undefined value in the data frame with a 0. So we execute this, and now we can see for blackberry undefined, the total tons is declared to be 0. Now, as we saw before, this data frame has not changed. In order to permanently change the value for any missing values, the result of fill missing command must be assigned to the data frame. So we again have to do DataFrame: equals fill missing data frame, 0 in order to update the data structure. Removing duplicates. Duplicate rows or duplicate entries in a given column do occur in many datasets. So say one was to mistakenly add another row to our data frame that contains some of the same information about blackberries, but the row is added under a misspelled label. So now we can see we've got 2 blackberries here, one that we've got 1 less R. So we do have duplicate values, but we do seemingly have one that was just a typo. By inspecting the data frame above, it is easy to see the duplicate entry, but duplicates may not be easy to find by inspection while dealing with larger data frames. The RDuplicate command returns a data series of true-false values that indicate if a row has a duplicate or not. So if we do RDuplicate of df, this returns for raspberry, grape, strawberry, all false, but then we see that blackberry and blackberry in fact are true. So what it's doing is it's comparing the rows and it's seeing that for this row of information here, this one matches up with this one here. So this result can be used to index the data frame in order to show just the duplicate rows. So if we do data frame and we index a data frame by a true-false data series, what we're actually doing is we're going to be filtering in essence. So now we can just do RDuplicate of df and we'll show you which of the rows are duplicates. So the converse of this is the RUnique command, and this can be used to show the unique rows in a data frame. So if a data frame is indexed by the results, the duplicate rows are essentially removed. So by default, the RUnique command marks the first instance of a row as unique, and then any other subsequent instance of a matching row as a duplicate. So let's do df indexed by the results of RUnique of df. This will give us back our original data frame, having filtered out the duplicate blackberry row with a misspelled label. The keep option controls if the first, last, or none of the duplicates are marked as unique. So if we do df are unique, df keep equals last, what we get here is in fact the last row from the bottom. So it's kind of a way to control which one you're choosing. So I think in this case we do want to keep the one with the correctly spelled title. So we'll do df and we'll index by are unique, df, and we're going to keep our first instance of BlackBerry. And now we are going to do a reassignment here, just because I did reassign and add an appended row. So we'll do df colon equals df index by are unique, and this will give us back our original data frame. Reordering columns. In the How to Change Column Name section, the column labels command was used to return the list of variable names. The column labels command also returns the current order of the columns. To reorder the columns in a data frame, use the DataFrame index notation to specify the new order for the columns and reassign this to an existing DataFrame variable. So here we can do DataFrame colon equals DataFrame with reorganize. So we'll reorganize it by having genus first, then carbohydrates, energy, country, total tons, botanical berry. So here's our reorganized DataFrame. So one important note, it is definitely not recommended that DataFrames with strictly numeric index column labels are reordered. This may lead to a conflict between the column label and the index position. Reordering rows. In the Reordering Columns section, the column labels command was used to return the current order of the columns. The row labels command returns the current order of the rows. So here we do row labels df, we see raspberry, grape, strawberry, blackberry. To reorder rows in a data frame, use the DataFrame index notation to specify the new order for rows and reassign this to an existing DataFrame variable. So now we'll do DataFrame is equal to DataFrame, and we'll index into it by blackberry, grape, raspberry, strawberry. And using the same as we saw before, rows, comma, columns, we'll do this for all columns using dot dot. Hit return, and this will give us back our reordered data frame. As we said before with the rearranging column section, it is not recommended that data frames with strictly numeric indexed row labels are reordered. This again may lead to a conflict between the row label and the index position. Sorting a data frame. One of the most common tasks while working with data is to order the data by ascending or descending numerical value, alphabetical order, or some other ordering. The sort command orders a data frame by values in a selected column. So for example, to sort the data frame in order of ascending carbohydrate value, we'll do sort the data frame, and as the argument here, we'll give carbohydrates. We can see this is going to sort in ascending order, so we're going to start with the lowest value and all the way up to the highest value here for grape. We can also sort the data frame by descending energy value, so we'll do sort energy descending. We can now see that we're descending, so we're starting with the highest value, which is grape, down to the lowest value, which is strawberry. And of course, it's also possible to sort a data series using strings. So we'll do sort data frame with respect to country. Here we'll see country, China, Mexico, Russia, United States. Filtering data in a data frame. One useful aspect of data frames is that they can be queried for subsets of the data frame that match a given query. Queries on data frames return a truth table whose entries are either true, false, or fail, depending on if a given element meets a given criteria. So for example, to return all the berries that have greater than 10 grams of carbohydrates per 100 grams, we'll do data frame carbohydrates greater than tilde and then the value 10. This returns a true-false table. We can see from this table that both grape as well as raspberry must have greater than 10 grams of carbohydrates per 100 grams. And blackberry and strawberry, they're false, so they must have less than 10 grams of carbohydrates per 100 grams. The truth table is a data series that can be used to index the main data frame. If the data frame is indexed by a data series of type true-false, it returns a filtered data frame. We saw this a little while ago. So we'll do data frame, and we index it by data frame carbohydrates greater than tilde 10. We can now just see the rows grape as well as raspberry, which have carbohydrates greater than 10. It is possible to use the add command to tally the values of any column of a data frame, including the truth table generated by the above query. So if we do add data frame carbohydrates greater than 10, we'll see that we have 2 false and 2 true observations. This is a quick way of breaking down our data frame. This means that for the 4 individuals of the data frame, 2 out of 4 are greater than 10 grams of carbohydrates per 100 grams, and 2 of the 4 have less than or equal to 10 grams of carbohydrates. More advanced queries can be created by combining several queries into one statement using logical operators such as and, or, etc. So for example, which of the berries have less than 10 grams of carbohydrates and greater than 150 kilojoules of energy? So we do DataFrame index by carbohydrates less than 10 and DataFrame energy greater than tilde 150. Since we're indexing in, this will basically give us a way of figuring out or filtering down to which of the entries meet this specific requirement. So in this case, it's just blackberries, which have less than 10 grams of carbohydrates and greater than 150 kilojoules of energy. So this is a very broad section. This was a very quick example. So for more examples, there's a help page called Subsets of Data Frames in our Maple help system that gives a lot more detail into indexing as well as doing subsetting of data frames. What does with do? If you've used packages in Maple before, you may have used the with command to load commands from a given package into Maple's top-level namespace. The with command for data frames does something similar. It takes any variables inside of a data frame and it makes those top-level variables inside of Maple. So if we do with of our data frame, we see now that we've created new variables called genus, carbohydrates, energy, country, total tons, and botanical berry. So these correspond to the data series which was previously present in the data frame. So if we do energy, this will give us back the data series for data frame energy. So this is very useful when we're using the query syntax. So if we now do something like energy greater than tilde 200, this will return the true-false table for that series of observations. Now similar to a package, you can also do unwith of a data frame. So if we do unwith of a data frame, energy is now back to just being an unevaluated variable. It is of course still available if you do data frame and then index into it by energy. Reshaping data frames. The transpose command returns the transpose of a data frame. This turns the variable columns into individual rows and the individual rows into variable columns. So let's here show transpose of the data frame. Now flipped it around, we now see genus, carbohydrates, energy, country, total tons, and botanical berry as the row labels, and we see each one of the berries as column labels. Applying a function to columns of a data frame. Many top-level commands, as well as commands in the statistics package, can be applied directly to data frames. However, many commands do not work with data frames. For many functions, there's simply not a uniform application that can be sensibly applied to the data series in a data frame. In cases where one wants to apply a function to only a single data series of a data frame, the element-wise operator can be useful. So for example, say we wanted to round the values in the carbohydrates column to the nearest integer value. The round command can be applied in the following way. So we do round, then we do tilde of data frame carbohydrates. So we now see these are the rounded values. To change the values for this column in place, reassign the carbohydrates column using the following. So we do data frame carbohydrates equals round mapped onto, or using this tilde element-wise operator, onto data frame carbohydrates. It may also be useful to apply a custom function to a data series. So for example, the following converts all the values in the energy column to joules from kilojoules. So we do a custom function using x, and we're mapping x onto x times 1,000, and we use tilde onto data frame energy. So now we have all the values in this column in joules instead of kilojoules. And here's another example. Let's do x. We'll map it on to convert x to a string for all the country names. And now we've got all string values for the country names. Changing the data type of a column. The data types option of the data frame constructor specifies the data types for each column of the data frame. The subs data type command changes the value of a specified data type and attempts to coerce the data contained in the column to that new data type. Let's start by looking at the data types of our data frame. Here we can see we've got a lot of anything, anything, integer, anything, 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 anything. So we can use the command subs data type to change the energy data series to have data type float. Now we can see here for energy, this does change the values. It does attempt to coerce this now to being float values. But it's also important to note that this is not done in place. So in order to have a permanent change, reassignment is required. So we can do data frame is equal to subs data type, energy float. And now we'll see float 8 in the first position here in our data types. Converting a data frame to other data types. It may be beneficial from time to time to convert all columns or some columns of a data frame to other data types in order to interact with other commands in the Maple language. The convert command can convert a data frame to matrix, table, array, or a nested list. So for example, let us convert the numeric columns of a data frame to a matrix. We'll use the convert command on these numeric columns. So there's a matrix. We do see that this is a lossy conversion. So when we're converting to a matrix, we are going to lose our metadata information. Our column headers, our row labels are disappearing. The following converts the columns with strings or names into a nested list. We do convert, data frame, list, comma, nested. And there's our result. Data frames can also be converted to arrays. So let's do convert of the data frame botanical berry into an array. In most of these cases, the conversion is lossy, as I mentioned before. The column names and row labels are discarded. The only case that attempts to keep the metadata is a conversion to table, where each table index is the row name for the entry value. So let's do DataFrame table here is equal to convert DataFrame genus into a table. So here we see table, blackberry equals this, strawberry equals this, and so on. And using the indices and entries commands, we can then pull apart the table, and this does attempt to keep some of that information around. But this is the only exception to the rule. All the rest of the conversions are going to be lossy. You're going to lose information about the metadata. Creating an empty data frame. In order to create an empty data frame, supply an empty list of lists as the first argument. So here we'll do new data frame is equal to data frame with an empty list of lists, columns equals column 1. Observations can then be added to the data frame using the append command. For more details, see the above section for adding a new column or row. So we can do new data frame, append to the new data frame, a new data frame with value 1, column equals column 1. We can also append another value. So we'll do new data frame 2, label equals column 2. Importing data into a data frame. By default, the import command returns data frames when importing from many tabular formats such as CSV or XLS. So here we can use import, and we'll use it for a CSV file that Maple is storing in its data directory. So we're using this base equals datadir option. This returns our data frame. Here we can see monthly passenger numbers for various time periods. I'll again go over to our context panel. I'm going to go up here, open this open, and let's show you a couple more things we can do with the context panel. So let's, to begin with, do a quick summary. I'll go to Summary and Tabulation, Data Summary, and we'll choose the monthly passengers column to give you a quick 7-number breakdown of this information. Let's look at this information in a slightly more visual way. Let's go back up to our data frame, go to Visualization, and choose to do a box plot of monthly passengers. There's a box plot, and so on and so forth. So basically anything you would want to have available to you from statistics is all available to you through this context menu. So we'll leave you with several more examples. These are great examples of working with data frames and data series. There's indexing a data frame. You'll find here examples of selecting, rearranging, and reassigning entries of a data frame object. Iris data. There's examples of summarizing data, computing aggregate statistics, as well as principal component analysis. Subsets of data frames. Examples of indexing and filtering columns and rows of a data frame. As well as finally statistics with data frames. Examples of using commands from the statistics package on data frames.